Alrighty, so this example that we're going to do now is a lot like the number 2 bell work that we did. So we noticed that we're trying to add 5 over x and 7 over y, but they do not have the same denominator. So you need to make them have the same denominator by finding the least common denominator, or in other words, like we just did, you're finding the least common multiple between x and y. Okay? So these next 4 examples that we're doing are examples where we do not have like denominators, okay? So if we look at this first one, 5 over x plus 7 over y, you need to decide first what the least common multiple between the denominators is. So x and y, they can't be factored. I can't simplify that anymore. So the least common multiple would just be x times y. All right, so if you're trying to make them have the same denominator, you have to multiply the numerator by what's missing down here. So x is missing a y from the least common multiple. So I have to multiply a y on top and a y on the bottom. This is just like what you did in the bell work. Over here, 7 over y, what is that missing? An x. So before you add it, I'm going to go ahead and simplify our multiplication. So we should have 5y over xy plus 7x over xy. I like to do that first before I add them, just to double check that, yeah, I really do have common denominators. Now all I have to do is add the numerators. 5y plus 7x over xy. All right, so I'm going to give you a second to copy down these 4 steps. Kind of like what we did yesterday, we're factoring the numerator and the denominator before we do anything else. If you can simplify it before you start, that's going to make it a lot easier when you're finding the least common multiple. After you factor the numerator and the denominator, you're going to find the least common denominator, or the least common multiple. Then you'll multiply to get the common denominator like we just did, and then we'll simplify. All right, so first things first, we're going to go through and factor this as much as we can. So 3, nothing can be done with that one. But let's look at 10x squared. Is there another way that we could write that that might make it look more simple? So 5 times 2 would be 10, and then x times x would be x squared. This is how we should rewrite that one out. Oh, Okay. So again, you're rewriting it as simple as you can. So 2 times x, that's pretty simple. I can't rewrite that a different way. But now we need to look at 5x squared minus 10x. Pull out a 5. And what else do they have in common? An x. So I'm going to pull out a 5 and an x, and I'm left with an x minus 2. Okay, now I like to do my work off to the side for finding the least common multiple between the denominators. It's totally up to you if you want to do that. okay? I'm going to go ahead and start circling things that are in common between the denominators right now. Again, if I circle it, I only include it once in my least common multiple. So I see a 5 over here, and I see a 5 over here, so I'm going to circle it. And I'm going to write that one time. Do you see a 2 in both of them? A 2 all by itself? No. An X? Yeah. Okay, writing that once. Do you see another X all by itself? No. And then an X minus 2? I don't see that in the first one. Okay, so I've written down everything I circled. Now I need to go back through and write down everything that's left over. So I'm going to multiply that by a 2, by an X, and by an X minus 2. So if you multiply the 5x and the 2x, you're left with 10x squared. So your least common denominator is 10x squared times x minus 2. Are we okay with that least common multiple? Okay. After you find the least common multiple, you're going to go through and multiply to get the common denominator. So in other words, you have to ask yourself, what's missing from this first denominator that is in my common denominator that I need? So right now, the first denominator is 10x squared. What is that missing? X minus 2. So that has to be multiplied in the top and in the bottom. Yeah.
I don't understand where the 3 and 2x went from here. Like, this is 3 over.
Oh, the numerators, we are not doing anything with them yet. All we're trying to do is try to find the least common denominator so that I can add these together. Okay? So I'm going to rewrite my original one. And then show that we're going to multiply the first fraction by x minus 2, because that's what's missing from my common denominator. Have to multiply it on the top and the bottom. All right, now if we look at the second one, I think this one's easier to actually look at the factored part and ask yourself, what's missing from this denominator that's in my least common multiple? 2x, good. Okay? You have a 5x and you have an x minus 2. So you have to ask yourself, what times 5x would be 10x squared? And the answer to that is 2x. So that's what needs to be multiplied on the top and on the bottom. All right, so let's go through and actually multiply by what it's in red and get our common denominators. Then we'll add them together. Okay? So up top, let's actually distribute the 3 too. So we'll do 3 times x is 3x, plus 3 times negative 2 is negative 6. And then we definitely need our common denominator down here, 10x squared times x minus 2. On the other side, I'm going to actually multiply 2x times 2x, 4x squared. And I know that I should have my common denominator now, 10x squared times x minus 2.
I'm not really sure how you did where you multiplied 5x squared minus 10x times 2x. How does that?
This one. So what you would have to do is distribute it through, and then you'd factor it back out. But I'm saving some time. I know that multiplying by 2x, we said that should give me my least common multiple. So all I did was copy down my least common multiple. If you didn't recognize that, you could distribute 2x to 5x squared and negative 10x, but then you'd have to factor this out. So if you recognize that you should get your common denominator, that'll save you some time. All right, what do I do next? add the numerator. So I'm going to put it in order. 4x squared plus 3x minus 6 over 10x squared times x minus 2. You would have to factor and simplify. I'm going to save us some time. The top is not factorable. So this is as simple as it gets. If you have something in the numerator that can then be factored, you would keep going and you would cross out anything that was in common like we did on Tuesday. Sadie and then Hazel.
I have a question. Why didn't you multiply the first 2x by x minus 2 to get, because when you have the 10x squared as x minus 2 denominator.
So we're talking about the first fraction?
No. Like you had 2x to start with, so you have to multiply it by x.
So that already had x minus 2 in it. If you look up here in the factored form, it was 5x times x minus 2. That already includes x minus 2. So I don't multiply it by that. It's just missing the 2x to get the 10x squared. Sometimes it's easier to look at the factored form to help you figure out what's missing from your least common multiple.
If you have it is only times x minus 2, you have crossed it out.
The reason you can't cross out the x minus 2 is because we're adding here. Okay. So this is as simple as you get.
Okay, but do you need to distribute or leave it as 3?
I would distribute what you have in the numerator on these problems because a lot of the times you're going to end up with a quadratic that can be factored. So I would distribute it through, and then you might notice that you get a quadratic that you can quickly factor, and then something will cancel out. Okay. Yeah. Yes. Like if it was like this, if it was 3 times 4x, then it would just become 12x. Okay, these are really good questions. Let's try another one. Okay. I would keep those 4 steps in front of you on your notes so you can kind of look through those as we work through these last 2 examples. This time we're subtracting. Doesn't make a difference on my steps though. I still do the same thing. But I am always going to start out by factoring what I've got. So I'll start with my first numerator over there. I've got an x. Can't do anything with that. 3x minus 15. I'm going to factor out a 3. And I'm left with x minus 5. Now we'll look at our second numerator. I've got 2x plus 2. Is there a greatest common factor there? 2. And I'm left with an x plus 1. And then we've got our quadratic x squared minus 4x minus 5. Factors of negative 5 that are going to add up to be negative 4. Go to negative 5 and negative 1, or plus 1. Okay. Okay. Now, we notice that there's an x plus 1 in the numerator and an x plus 1 in the denominator. Why am I allowed to cancel those out? Because they're multiplying. They're multiplying. They have that in common. X plus 1 divided by x plus 1 is 1. You could not cancel it out if it was in the other fraction because those are being subtracted. But here, since it's one right on top of the other, you can go ahead and subtract it out. When that happens, it's kind of nice for you. It makes you have less to deal with when you're trying to find a least common denominator. So that's what you're left with now in the denominator. You've got a 3 times an x minus 5 and then an x minus 5. Are those as factored as simple as you can get? Yeah. What would the least common multiple be between those two? 3 times x minus 5. How did we figure that out? Good. They both have an x minus 5. That would be something that you could circle and you would rewrite it once over here. A 3 is left over, so that needs to be multiplied. Okay. So now, when you're trying to make them have a common denominator, let's look at the first fraction. X over 3 times x minus 5. Is that missing anything from our least common multiple? No. So do I have to multiply that by anything? No. So move to your second fraction. The denominator is x minus 5. What's that missing? A 3. So you have to multiply a 3 on the top and a 3 on the bottom. We did not change our first fraction. Now on the second one, I just have 2 times 3. So I have 6 up top. And now I have a common denominator, 3 times x minus 5. Now all we have to do is subtract. X minus 6 in the numerator, 3 times x minus 5 in the denominator. This one is better than the last one. You're going to see more like this one on your homework. All right, this is our last one. I'm going to give you guys a few minutes to start and factor it. See if you can find that least common multiple. All right, so on the first one, we can't factor 3x squared, but we can write it in a more simple form. 3 times x times x. Nothing I can do with x. I can factor 9x squared minus 12x. So what did you pull out? What was the greatest common factor? 3x. X is in combo. Make sure you notice that they both have the 3 in there. Then you're left with 3x minus 4. So when we go through to find our least common multiple, yeah. Laura noticed that over here, we've got an x up top and an x in the bottom. So you can cancel those out right away. So you're just left with a 1 up top. If you didn't recognize that and you kept going, we're still going to get to the same place. Okay? So now if we go through, they both have a 3. Now do they have anything else? No. So I'm going to write that 3 one time. And now I have an x times an x left over, so an x squared, and then a 3x minus 4. So that's the denominator that we want them both to have. So if you look at the first fraction, you have 3x squared. What is that missing? 3x minus 4. That needs to be multiplied on the top and the bottom. Now the second fraction, it's easier to look at it in factored form. You have 3 times 3x minus 4. What is that missing? X squared. It's missing that whole x squared term. So you're going to multiply x squared on top and on bottom. Exactly. If I didn't recognize that the x's could be canceled, I would have just multiplied it by 1x, because that's what it was missing. Now in your first fraction, you have 3x minus 4 in the numerator. Kind of looks like a mess what I have right here in the denominator, so I'm just going to copy down my least common multiple. That's what my denominator should be. 3x squared times 3x minus 4. I'm adding to that in the numerator 1 times x squared, and my denominator 3x squared times 3x minus 4. So when I add the numerators, I'm just going to write it in order. X squared plus 3x minus 4 over my common denominator. Now let's look at the numerator. Can anything be done there? It can be factored. So should I do that? Yes, because in its factored form, that's as simple as you can get. So we're looking for factors of -4 that are going to add to be 3, 4, and -1.